Hello. Okay. I hope I'm audible and visible to everyone. Uh, Welcome back. Today is the last and concluding session of the Rhino Masterclass that you have been a part of. Uh, we will be covering a lot of important closing notes on modeling with Rhino. We will also see one more example of how to use different tools that we learned today. We will also be designing and modeling on the fly, as in, if you remember, we were discussing about this idea of not just tracing a geometry and then modeling it in Rhino, but to start designing in Rhino and using the interface, using all the tools, and also using Rhino as a design environment. So we will see an example of how we're going to get to that. Also, we will see how to make some process renders, something like a process documentation of how and what steps you take to finish a model. So this documentation can sort of help you and others as well to follow a certain process and then come up with a final outcome that they were intending to. You could also document this process to slightly tweak it the next time and get some more iterations of the initial outcome that you had. Also, this entire process will help you in understanding visual programming in a more smooth way. Also, as our challenge asks you to submit a process render as the form of as a form of a documentation of how you went ahead and finished the entire challenge following all the steps that we had asked you to do. So let's begin. I hope you guys have practiced what we did last time. You tried to finish the Danish Pavilion by Big Architects. Probably you also tried to model the Oceanographic in Valencia by Felix Candela. I hope this was a much easier building to model than the Danish Pavilion that we saw. So yes, let's move ahead and see some more commands to modify surfaces. This time to modify surfaces, polysurfaces, and to extract different geometries from each other, and to manage them, to then remodify them, and then go back and make something else with it. To begin with this entire summary of the whole thing, I will start by making modeling the oceanographic for you right away, so that we will also see some more commands while we do it. So let's go ahead and model this building. Okay. So let's first understand how the oceanographic looks. Well, if you notice, it's just this one little petal, I would say, that gets copied around a center around 8 times. So it's basically starting from an octagon, and then it has some lines which are extended in a weird kind of a catenary. And you would also see that it's not just a single catenary on this edge, like on each petals, but there's also a catenary that connects these petals to its diametrically opposite cousin, I would say. So understanding these two ideas of the catenary and starting with an octagon, let's jump in and start off with the oceanographic. So the first thing that I'm going to do is, of course, make an octagon. How to make an octagon? I would just type polygon, this tool which gives me the ability to make a polygon of any number of sides. So I will start from the center, because it says, what is the center of the inscribed polygon? Okay, that's my center. Now it's asking me, what is the next corner of the polygon? I could give a number to determine where this polygon needs to end. Also, by default, your polygon might have 6 sides. To change that, just go in and just type 8, and you would have 8 sides, an 8-sided polygon. Let's type a number. Let's say this has a radius of 25. Okay. And we have left clicked and plotted it. Now, I'm going to use one of these sides to make the curves, to make the petal, and so on and so forth. But to do that, I'm going to use the front view, because it's going to be much more easier for me to draft and so on and so forth. But as I notice, none of these edges are aligned to the front view or the right view. So I'm just going to play a nasty little trick. I'm going to rotate this and try to get the side on one of the orthogonal directions. So I'm going to say rotate from the center, and I'm going to say plonk it to the midpoint and get it over there. Okay, so there we go. We have it aligned sort of to the orthogonal directions, and now we're going to use this. So how we're going to use this is, we will make some reference lines and reference points, and then we will use those points to draft the curve that we have in our mind. Let's have a look at the curve again. So the curve is sort of like a catenary, but it's tilted outwards. So to take care of that, let's just make a line vertically. I'm going to say something like, let's say 25 again. Okay. And then I'm going to extend this line on this side, as in I'm going to make another line to drop a point which will then help me to make the tilted catenary. So let's say I'm just going to say something like 12.5. I don't know, just half of it, so that the tilt still remains, but it's not too much. Okay, so I have this point now in space, and now I can understand where I need to plot it to just use it to make a curve. So I'm going to take this one point, the second point, and the third point to make the curve, and I'm going to use interpolate curve or interp curve. Okay, start of curve, this. The next point is this. I'm just going to make sure that it's this one. Yes, it is. And the third point, which is this. And now I'm done. So I'm going to press enter or space. Okay, so I have one of the petals. Okay, now I need, okay, so I'm done with this part of the catenary, but I still need the other catenary that goes and cuts this building into half. Yeah, let's just look at the picture. This one, this catenary is what we need now. So we're going to follow a similar process, which is to have some reference lines, which will give us some points, and then we'll use them to make an interpolated curve. Okay, but how do I do that? Well, First, I'm just going to mirror this on the other side and have some reference for me to work with. Second, I'm going to make a point somewhere here that is at a certain height, let's say 12.5, the half of what we have been using for now. So I'm going to start with the origin. I'm pressing Control, clicking on it so that we can draft in the Z-axis. And I'm going to type 12.5. And there it is. So this is the point that I'm going to use. And say interp curve again, 1, 2, and 3. Here we go. So we have the first catenary, the second catenary, all taken care of. Well, we have this, but we need to make the petal, and the petal is going to be a surface, precisely this surface, one of those. And for that, we need something to make it exactly following the same dimensions, sort of cutting off at this point, and so on and so forth. So I'm going to introduce this command to you to make surfaces, which is called network surface. So a network surface basically is using a network of curves to make a surface. Basically, it needs some boundary curves to understand where the surface is ending. Okay. So I have this curve, the other curve, but I need some curves here that will sort of tell the surface to end at these points. So I'm just going to use this point again and make some new curves. 1, 2, and 3. If I go to the top view, tells me that, okay, of course, this is going to be the boundary for this side of the curve, of the surface, sorry. And the other one is this. 1, 2, and 3. Okay, so we're done. And we have the boundary curves which are going to tell our network surface where to end. Okay, at this point, I'm just going to make the trash layer and add some of my some of the reference lines into this so that they don't disturb us while we are taking decisions. This goes there, and we have those. Well, so we have these boundary curves 1, 2, 3, and 4. Well, as you can see, these boundary curves are not really boundary curves. I mean, they are extending on the other side, and we don't really want that. We want this curve to stop at this point, and we don't want it to extend on the other side. So there's the same for this curve and this curve as well. So what we're going to do now is we're going to split these curves at this point so that they don't extend on the other side. We're not going to use trim, but we're going to use split. What split does, it just breaks a geometry into 2 parts, whereas trim removes the other part that you don't want. So we're going to use split and not trim. So I'm going to say split, and says select the objects that you want to split. So these are the objects, and the cutting object. This is the cutting object. Okay, so now it says 3 curves split into 6 pieces. So make sure always that the cutting object is touching the objects that are being split. If the cutting object does not touch it, then it's not going to split at all. So there you go, we have these curves, and now we're going to use them to make network surface. So now it says select curves in network. So I'm going to select 1, 2, 3, and 4. These are my curves. So as you can see, it has given me a preview of how my geometry is going to look. And this is how it looks. Okay. Well, you can still make it more loose. So yeah, we're going to take this option and we go ahead. Now, always make sure that while using network surface, you select the curves in a specific direction. Like for example, I selected this curve, this curve, this curve, and then I selected the last curve. So doing so, I'm sort of telling Rhino that these curves are aligned in the same direction of the surface, and this curve is on the other direction. So if I jumble it up, if I say 1, 2, 3, and 4, then it'll get confused and it might not give me the same results. So in network surface, always make sure that you are aligning the edges of the surface in the right direction. Okay. Just like you have coordinate axis in X, Y, and Z, on surfaces you have directions which are U, V, and W. So we first selected the curves in the U direction and then the V direction. We will see this more in detail when we start extracting iso curves from surfaces. So now we have one petal, and all we need to do now is just to array. Where array is when you copy something in geometric progression, and you copy something based on its linearity or its or when you rotate it while copying it. So we're going to use the polar array, which is similar to the polar array that you have in any other drafting software. So I'm going to use that, and I'm going to say array. So the moment I type array, there are several options. The one that we're going to use is array polar. Okay, so the center of polar array is of course this one. Number of items, of course 8, and the angle that it has to fill, oh, it's the entire angle, 360. So there we go. It gives a little preview, and we have it. So there we go. We have the final structure, which looks like this, and the geometry is all set. Well, as you can see, the actual structure, it also has another surface inside, because of course this is a habitable space and needs some facade on the outside. So of course we're going to make that as well, because that's an aspect of this form which makes it more complete. So it's not just this, but it's also that little surface over there. So let's make that. Now, as we understand, now that we are done doing this, these are individual petals. Now we need to join them. So let's do that. Let's just select all of them. We can also just say select surface, and all of them get selected, and we're going to say join. Okay, so now they're joined into one surface. Because the geometry is clean and it's not self-intersecting, also the fact that the curves are smooth and they are sort of equidistant control points, the join was very easy and homogeneous. If the surfaces are self-intersecting, if they need to be rebuilt, then the join will not be clean. Also, doing Boolean operations on these surfaces would be slightly tricky. So always keep that in mind. Have smooth and clean geometry, which will result into smoother operations, modifications later on. So we have this structure, and now we just need to make the facade for it. So let's have a look at the facade and how it's made. Hang on. Yeah, there we go. So the facade actually is a surface, a single surface, let's say, that has two boundary curves. One boundary curve is the ground which is something like basically it's a circle, and the second boundary curve is the top edge of the surface. Okay, so let's keep that in mind. We need two curves, and then we're just going to loft between them and achieve the surface. So the bottom boundary curve is very easy. We just need to make a circle because that's what it is. Okay, so we have the circle now, and it's this one. I'm just going to put this guy in the trash so that we don't get confused. Okay, so we have this. Now, how to achieve the other boundary curve? Are we going to make interpolate and then curves again? No, not really. We already have it. We just need to somehow pull it or push it on the other surface. So we need to project it or pull it on the surface so that we get the result which will help us in making the loft. Okay, so I'm going to try project curves and points. Okay, this is the curve that I want to project, and the surface that I want to project to is this. Oh, I didn't actually have to turn it like this. This was just I was just being silly. Okay, so the moment we project it, it's there. I mean, this curve is now projected onto this surface, and it's actually gone on and drafted itself. So now we just need to go ahead and loft. I'm going to select them. This part is easy because, I mean, it's easier to loft them because there are just two curves, and in no way are you going to mess up with the sequence. So the two curves are selected. Now we just need to take care of the seam. So let's do that. Oops. So I'm just going to drag the seam, but I'm going to say that, okay, let's see if the quads can help us. Okay, this is one quad, and the other one should be somewhere here. Okay, yes. So now the seam is clean and it's aligned and everything, and they are in the same direction. So let's go ahead and loft. We're obviously going to use the tight because yeah, that's exactly what we want it to look. And there we go. There it is. The petals or the roof and the facade. Okay. Do we have any live attendees right now? Okay. There is one person. So you can go ahead and try this entire process. I hope I wasn't too fast. The only new commands that we saw in this exercise were the network surface and the polar array. So and also the project. So I think polar array shouldn't be something new. It's something that you have done already in various other softwares. But network surface, yes, you won't have done this before. And also project to some extent. So yeah, just go ahead and try. I'll just give you like 1 or 2 minutes. And if you have some doubts, you know what to do. Yeah. Okay. Well, if I'm sure you're not done doing it yet, but yeah, probably you can try it later and you can see the video and then try it again at your own pace. But I hope you don't have any doubts from the three commands that we saw. Because and if you do, maybe yeah, we're going to use some of the commands in the next exercise as well. So that should be okay, I guess. Okay, so moving on. Yeah, I am just going to put this in its own layer. Uh, and just shut it out, and we're going to use the same file to make something else now. Oops. Okay, no questions. Let's go ahead. So now what we're going to see is something that we discussed at the beginning of the session. We are going to design a skyscraper, let's say. We're going to design a skyscraper on the fly without any preconceived sketch or idea. It's just going to be a tall tower, a high-rise building